These are questions 12, 13, 14 on chapter 3. First off, how many grams of nitrogen are required to react with 2.3 moles of magnesium in the following process? 3 Mg plus N2 produces Mg3N2. So we got 2.3 mole of magnesium over 1 times the ratio of magnesium to nitrogen, or nitrogen to magnesium, because they want us to tell them how much nitrogen we got. So for every nitrogen, actually we got 2 moles of nitrogen because it's N2. So for every 2 moles of nitrogen, we've got how many moles of magnesium? So right here we got 3. So 2 moles of N for every 3 moles magnesium. Okay. This lets us cancel out the moles of magnesium. And now we got 2.3 times 2 over 3. And then we should actually just do it all one big piece, one procedure. So now we've got to go from moles to grams. Now the grams of nitrogen tells us right here they want us to use 14.0 grams per mole. So N equals 14.0 grams per mole. Alright, so we got 14.0 grams of nitrogen for every mole that we got. And that should give us 2.3 times 2/3 equals 1.53 times 14. And this gives us 21.466, and just repeats all over. We can actually simplify this to 21.5, which is A on the first choice. 21.5 grams, don't forget, of nitrogen. For number 13, there we go. Whoops. How many moles of H3PO4 are produced when 20.0 grams of HCl are produced by the reaction PCl5 plus 4H2O produces H3PO4 plus 5HCl. So same thing. We start off with the 20 grams of HCl. Okay, 1. And now we got to do HCl to H3PO4. In this case, for every gram, we got to go to mole first before we do our little ratio. So HCl should be H equal to 1.008. Cl is equal to, I wrote it down, 35.45. Okay, so you add these together for HCl and you get 1.008 plus 35.45, 36.458. There we go, 458. So 1 mole of HCl, 36.458 grams of HCl. This cancels out. So now we got 20 over 36.458 should give us the moles. And now we can go from mole of HCl to mole of H3PO4. So of course we want to end up with the mole of H3PO4. We got one of those, 1 mole of H3PO4 for every, how many moles of HCl? Well, we got 5 mole of HCl. That would equal a number, but really all they want to see in the question, the answer, it's not even a real number, it's just like what process. So we start off with 20 divided by 36.458, okay, which is 36.5 in the answer choices. So we can see that from just this process we can eliminate A, C, and D because they're dividing 20 by 98, A and C, and D is dividing 20 over 35.5. The only ones that are doing this, 20 divided by 36.458 or something similar, close enough, are B and E. Now, we also have to go from mole of hydrochlorine, HCl, to mole of H3PO4, and we divide 1 over, we divide by 5, which E does not do. That means our only right answer is B, because this whole process is 20 over 36.5, okay, divided by 5. Same thing. Okay. Over here for the reaction, 2 aluminum plus Fe2O3 produces Al2O3 plus 2 Fe, 2.5 grams of aluminum, which weighs 27 grams per mole, and 7.2 grams of Fe2O3, which weighs 159.8 grams per mole, produce how many grams of 55.9 grams per mole? So here we actually have a good practice. We can go from aluminum, because they give us aluminum right here, 2.5 grams of aluminum. Okay. And they want us to figure out how many grams of Fe are produced. So we got to go from grams of aluminum to grams of Fe, or grams of iron. So 2.5 grams of aluminum, we got to turn that into mole. They tell us 27 grams per mole, so we can just use that. So 1 mole of aluminum weighs 27 grams. Okay, so we can cancel out the grams of aluminum right there. Now we're at moles of aluminum. From moles of aluminum, we can go to moles of iron. So here we can see for every 2 moles of aluminum, okay, we end up with 2 grams of iron right here. 2 moles of iron. Really, that's just 2 over 2, which is 1. But we need to do it. Mole of aluminum cancels out, up on top. And now that I'm at mole of aluminum, I can go to the grams of aluminum. So they give us the grams of aluminum, 55.9. So 55.9 grams for every mole. Okay. Here we go. This cancels out. All in all, once you do this, 2.5 over 27. Let's do it. 2.5 over 27. Okay. So you end up with 0.093, let's say 0.093 times 2 over 2, that's just 1. So if you want to do it, you could do it, but you don't have to. It's just going to give you 1 again. Times 55.9. Okay. And you get 5.1987. 5.1987. This is grams of iron. So go ahead, try out for the second one. You have to go Fe2O3. But for Fe2O3, they give you 7.2 grams of Fe2O3. Okay. Over 1. So go ahead, you can pause the video. Try to go from Fe2O3 to iron, because again, they're trying to figure out what's the amount of iron that we're going to get. So, go ahead. Now, if we look, hopefully pause the video to try to do it on your own. We got to go 7.2 grams Fe2O3. They give us Fe2O3 weighs 159.8 grams per mole. So 159.8 grams, 1 mole. We'll do Fe2O3. So, oh man, I gotta do Fe2O3 a bunch of times. Grams, cancel out grams. Now we're at moles. And we can go from mole of Fe2O3 to mole of Fe. So here, Fe2O3, we've only got 1 mole. And again, 2 moles of Fe. So for every mole of iron oxide, I guess, Fe2O3, dang, there we go. Okay, sure. We have actually 2 moles of iron. Okay, now that we're at moles of iron, we can go to grams. Here, grams of iron is the same one we got up here, 55.9. So 55.9 grams of iron over 1 mole of iron. Okay, so that cancels out this. Oh, forgot to cancel out iron oxide. Now we just got to do this whole process. So 7.2 over 159.8. 7.2 over 159.8. Should get something like 0.045, something around there, times 2 over 1, which is just 2. And then that times 55.9. Hold on. I put it equal. That shouldn't be there. It should be times 55.9. Okay. So now we are at the 5.037 grams of iron. So now here you can see that which one's gonna create less. Well, the 5.037 is the least, so we gotta use the iron oxide, which is our limiting reagent. Okay. The process that starts off with 7.2, immediately you can see on number 14 your answer choices are 7.2 for A and 7.2 for E. Since that's our limiting reagent, that's going to be the one we have to use. We can't use B, C, or D because they all start with 2.5, which is aluminum, our excess. But we can't make more than this. So A and E are the choices. But if we could looking at it, we got 55.9 times 2 over 159.8. Then we got 55 over 159.8. So A is the correct one because they got 7.2. Okay, there you go, they got check. They wrote the 159.8, check. They wrote 55.9, which is this one, check. And then they wrote the 2, check. E does everything except for the 2 mole. So it doesn't convert from mole of iron oxide to mole of iron. Okay, so there we go. Should be A for number 14.